All right, so this is section 7.2, but when they say parabola, you might be thinking y equals x squared, which is a parabola. That's a function. You might also think x equals y squared, which is a parabola. It's not a function. If you switch x and y, things happen. All right, but it's not a function because it doesn't pass the vertical line test. But so you might know something about the parabola already, but this is the parabola revisited, or the parabola chapter 2. Because we're going to talk about things that you don't normally talk about when you're just looking at parabola as a polynomial, and I don't know, maybe this other one, if you've seen that before. But this is a very different take on the shape that's a parabola. So, analyze parabolas with vertex at the origin. Okay, so vertex at h comma k, and then they slip this. We won't really be doing word problems, but we'll see what we have here. All right. So they kind of missed something here. When they say analyze, analyze is a pretty big word. You don't even know what that means yet when they say analyze. All right. So here's a very interesting definition of a parabola. It's not what you'd think. It's a collection of points that are, we'll see an illustration of this in a moment, the same distance d from a fixed point, f, called the focus, and a line called the directrix. So the distance is the same. So if I go kind of perpendicular here, it's kind of obvious to see that this distance is the same as that distance, but it's a collection of all those points where the distances are the same. So, and let me explain. The focus is not part of the parabola, and neither is the directrix. You get this curve that kind of wraps around the focus, and as it gets farther away from the focus, it has to get farther away from the directrix. I'll see if there's a better picture of that. But all right, so there's this tradition with the parabola that we measure how wide a parabola is. Well, parabolas are infinitely wide, but we measure how wide it is at a certain point. At the focus. It's kind of like you have a circle, you measure how wide it is through the center. Well, if you have a parabola, there's no, that goes on and gets wider and wider, right? Where do we measure? Well, we measure it through the focus. In the case of the circle, this is called the diameter. In the case of the parabola, it's called the latus rectum, and we'll get to that when we get to it. But how big is the latus rectum? How do we measure these things? We know this is the vertex. Well, do it down here. If I have a parabola, that's the vertex. Focus might be right about there. Well, that's not to scale. All right. Focus might be right about there. And we measure how wide it is here. All right. So there's a reason why when they talk about a parabola, they write it this way. So let me do this in practice. If I said y squared equals 8x, notice that 4a there. Well, I can rewrite this. I can factor out the 4, and I can rewrite it as y squared equals. By the way, notice I'm solving for y squared. Normally we don't do that. But all right. I can rewrite this as 4 times 2x. I can do that. Why would I want to do that? Well, because I want to match it up with 4ax. So a is 2. Now, personally, I like to think of a as possibly being negative. They don't. They talk about a being positive always. If there were a negative sign, that would certainly influence things here. But what is a geometrically? A is, or in other words, what's 2? Well, 2 is the distance from the vertex to the focus. What is 8? 8 is the length of the lattice rectum. So sometimes I call this a big T, where this length is A, and this length is 4A. During the regular semester, students will ask me, what was that big T you were talking about? Yeah, it's this right here. And I don't know if you remember, I kind of erased my graph. I mean, the focus would have been way down here on this one, and yeah, I erased that and drew it again because this is about right. In other words, the representation, the map, I guess, of a vertex, focus, whatever length that is, this width of the thing, the diameter of the thing, is 4 times that. So if that's A, it's 2A in this direction, 2A in this direction. How did I start? By going from the vertex up to the focus and then this direction, this width. So if I see an 8, I instantly know this is 8. Pretty quickly know that A is 2. And so I have these 3 points of the vertex, of the parabola. The vertex and these points on the ends of the lattice rectum. All right, well, they kind of did it backwards here. Find the equation, same problem I just did. Well, actually, I didn't draw that problem, by the way. I haven't drawn this one. No, I'm not saying I drew that one. Let's see, did I? No. Y is being squared, so this particular graph we know y equals x squared, and that kind of tells us that's what you get. When x is being squared, you get a parabola that holds water that goes up like that. When y is being squared and there's no minus sign, the parabola is going to go this way. So, I mean, I had a graph here and I wasn't really drawing it. That's not a good thing. There's my focus. 2 this way. 4 this way, 4 this way for a total of 8. And I have my 3 dots, and that's 3 dots enough. 3 dots is enough, if I know this shape, to draw my parabola. All right, so that's the graph of this. And I don't know, graphing these quickly is nice, but also they might ask you, what's the focus? Well, it's an ordered pair. In this case, it is 2, 0. What's the vertex? 0, 0. What's this point? The end point of the lattice rectum. Remember, I went 2 this way and 4 this way, so it's 2, 4. And this one would then be 2, -4. And again, clearly it's not a function because it doesn't pass the vertical line test. But we kind of knew that because y was being squared. In this section, we always solve for the squared variable. we isolate the squared variable. And so that's why I call this, revisiting the idea of parabolas. All right, so they give us this idea in reverse. They say, okay, you've got this vertex at 0, 0. You've got this point 2, 0, which is the focus. So instantly we know A is the distance between the vertex and the focus. So this is the equation that we would use. We just want to drop a 2, the distance between these 2 points, in here for A. And so it's 4 times 2 times x, which of course is this equation. So this is the answer once you figure out that A is equal to 2. Well, once you substitute that A is equal to 2. And so they ask for the equation. And that's the equation. Of course, at some point, they're going to want to graph it. And we finally have an illustration of this, more of a computer-drawn one. So I hadn't written the word down, but I said that the width or the span, the measure of a parabola is traditionally taken through the focus, and it's called the latus rectum, and it's that length right there. So the idea is if you have something like this and you want to plot it, you can plot it fairly quickly. It looks like they're plotting points to do this. They're not doing this geometrically, but these points determine the latus rectum. Again, why geometrically? Once you know the focus, you go twice that in this direction. So if that's 2, I'm going to go 4 in this direction and 4 in that direction. What they're saying is, if you know the focus and x equals 2 for the focus, you can plug in 2 and solve. And so they're doing it more algebraically than geometrically. But gives you that value. All right, let's look at another one. This one's almost the same as the last one. All right, because y is being squared and it's positive again. So we'll talk about when the vertex isn't at 0, 0, but there's the vertex. Since A is 1, I'm just going to move forward 1. Since the latus rectum is 4, I'm going to go 2 in this direction and 2 in this direction. And it's going to be that picture. The one thing I didn't add to the picture, which really doesn't add any value to the picture, is the directrix. So the directrix is the line in the opposite direction as the focus. So if we know the focus is this direction, and the focus will be to the right, if I want to say A is positive, the book doesn't say A is positive. The book says A is 2 in either situation. But if there's no negative symbol here, if you have y squared, nothing negative, you're going to open in this direction to the right. And on the opposite side is the directrix. So if I got rid of this parabola here, basically what you start with is, you know the directrix, it's -2, and the focus is at 2. I don't even let me draw the directrix. It doesn't really help to draw the directrix. It doesn't help, enhance your graph, but they might ask you to do it. In this case, the directrix was -1, because remember the A, right? If I match this to 4ax, A is 1. And if A is a +1, focus, directrix. You will have questions where they ask you that. I say don't draw it, but they might ask you. And they'll ask you for these points, the points on the latus rectum. So just to be clear, what the author is doing is the author is not physically moving like a chess game. Move 1 and then 2 this way. Whatever you go here, go twice as much. The author's not really using geometry. What the author is saying is, okay, we have this thing, y squared equals 4. And I have to let x equal this, in this case anyhow, this number, well, it is this number here, the x value of the focus. So if I put in x equals 1, what would I get? Well, remember, this is not a function, so we will get a plus or minus, but what we get is y squared equals 4 times 1. Or y squared equals 4, so we do get y equals plus or minus 2. So the ordered pair, if I'm being a little lazier than the author, would be 1 comma plus or minus 2. Now, I don't even think there's a way to type in this 1 comma plus or minus 2 with a plus or minus. Plus or minus isn't the keyboard key or something. So even though that's what I might get, what are the answers? Well, 1 comma negative 2 and 1 comma positive 2. Those are the two end points of the latus rectum. All right, now here's what I was saying. The author always says A is positive, and technically A is a measurement, so technically that's true, but here are the things that a negative sign does. So the two graphs we had, there was no negative sign. So you start at the origin, the vertex at the origin, and the focus is, correctly, A in this direction. So here's my A when I see something like 4 y squared equals, let's do 8x. A would be 2. Go up 4 this way, and I draw my parabola. Well, what about this when I see a negative sign there? Well, the author's saying A is still positive, but if I wrote y squared equals minus 8x, you could be forgiven for saying, I don't think I have any questions whether he specifically asked what A is, but for thinking, if you match this up to this formula, well, you'd get 4 times negative 2x. That's true. It is 4 times negative 2x, but the author is very clear about A. Let's just say A is the absolute value of this. But what does the negative do? Negative plays a very important role. It tells us that we have the vertex and we go to the left because of the presence of the negative sign. And that's just what the author says. If you have a negative sign, it opens to the left. But he's not going to say A is negative. All right. Well, if it opens to the left, what happens? The directrix goes to the other side of the vertex. You still go 4 times as much total, but twice whatever A is. You go 2A this way and 2A this way. Gives you more points. You get that. All right. What if you had x squared? Actually, that's what you're used to. You're used to, the first parabola we all learn is y equals x squared. And we know that opens up, it's a function. All right, so no surprise here. But they're not writing it the way we're expecting to write it, y equals. We always start with the squared number first. And let's just put an 8 there. And what do we have? Well, A is positive 2. Again, A is always positive, but A is 2. And there's nothing negative involved here. So vertex, and you go up A. How far do you go in each direction? 2A in each direction. to give you the endpoints of the latus rectum. Final situation is, what if you had a minus, like x squared equals minus 8y? Well, minus means you're going to go down to find the vertex. Still going to go, and then to the left and to the right to find these extra points on the latus rectum. And if you wanted to draw the directrix, you would just, the same distance you went to find the focus, you go that distance to find the directrix. All right, so I'm really emphasizing the images here, the pictures, that kind of thing. Obviously, the way the book's going to write the question, the website's going to ask the questions, it's going to be a little different. It's not going to have you draw a lot of things. It's going to have you, answer these questions here. All right, so if I look at this, the other saying, use this formula with a built-in minus sign. In other words, use the formula that starts with an x squared, has a 4, has an a, has the other variable, and the one with a built-in minus sign. All right. Again, personally, I really just want to say a is -2. It doesn't hurt anybody to say that, but again, it's technically a is 2, and we just have a different formula for when it's negative. All right, so to understand what's going on here, we start with a vertex at 0, 0. Again, we'll see why, but when x is 0, y is 0. And then since a is 2 and there's a negative, what am I going to do? I'm going to go to -2. So I travel 2 in this direction to find the focus. That allows me to go 4 in, if I go 2 this way, I've got to go 4 this way and 4 that way to find these other points, the endpoints of the, no, not there yet. To find these other points, I don't know why they haven't mentioned that yet. They did mention the directrix. It's up here. And here's where they have the points. We know the graph is, opens down because of the negative sign and the fact that x was being squared, not y. And now they're going about finding these points. They use a very algebraic way of finding it, but I'm saying, boy, I almost lost the image here. It was x squared equals -8y. So you know what I know right away? I know that 4a is equal to 8. So that's how wide this thing's going to be. It's like, take what's visible and use it. Use that. 8. So if that's 8, each of these are going to be 4. I don't even know what a is yet, but if I divide by 2, I'll get, or by 4, I get a is equal to 2. So that tells me what this distance is like. If you have that, you have an image of the parabola in your head. All right, so I want to say this was just the first part of this. We'll look at this, but this one. All right, so they gave us the focus. If they give you the focus and you find out that a is 3, it means you're going to go twice that much in this direction, twice that much in this direction to find these other points. So it gives you those points. If they ask for the equation of the directrix, if I go 3 in this direction, it's -3. Y equals -3 is that horizontal line. What I was saying is, so far we've only talked about the vertex at 0, 0. And I kind of want to get off of that, so I'm going to kind of flip through this one and get to one where there's an h, k. You shouldn't be terribly surprised about this. If I replace y squared in the previous page equals 4ax, but what am I going to do? Well, of course, I'm going to replace x with x minus h. That's what we do when we want to see a translation or a shift of a graph. And I'm going to replace y with y minus k. That would be a vertical shift, just like we learned in the circle, not in this section, but in other sections. So I kept on saying earlier that the vertex was 0, 0. Well, that's because I wasn't subtracting anything from x and I wasn't subtracting anything from y. Now that's not necessarily the case. So we have something much more interesting. So we have all of this. All this will be obvious when I draw it, but we have the vertex not at 0, 0, but at 1, negative 2. The focus is at 2, negative 2. And let's take it from there. No picture? Man. Okay. I'm going to start with a picture. Here's 1, negative 2. 1, negative 2. Here's the origin right there. So 1, negative 2, that's the vertex. 2, negative 2 is the focus. So what is A, and is it positive? Well, A is always positive, but you know what I mean. A is 1. So if that's true, I know to graph this, I'm just going to go 1 this way. I have to go twice that distance, so 2 this way and 2 this way, for a total of 4a in this direction. So I get my graph very quickly just by drawing these two things. All right, if I want 1 in this direction for the focus, I want to go 1 in this direction, which is the line x equals 0. And that pretty much gives me my image. All right, what did I need to know? I knew, well, actually, I kind of needed to understand something. When they gave me this was the focus and this was the, vertex, this was the focus, that instantly gave me the correct formula to use. It's y minus k squared equals 4a x minus h squared, as opposed to, for example, x minus h squared equals 4a y minus k. Y is being squared. How do I know that? Because it takes y being squared to get a parabola opening left or right. If x is squared, the parabola is going to go open up or down. So just want to just say, and then it's positive because of the way it opens. So we need to be aware of all of that. I just needed to find A. That was really it. Well, no. Well, I say find it. Remember how they gave us this point right here, that's H. 1 is H, or H is 1, and K is negative 2. So if I subtract the negative 2, I'll get y plus 2 squared. We already know A is 1, positive 1, so 4a just becomes 4, x minus 1. And that's the way we leave it. That's the way we want the graph, the equation to look like. And so here we are. The author did, I don't know, this idea of graphing last. Not a fan of that in this case. I think it's much better to graph it first, and then you see everything the author is telling us. You see that H is 1, you see that K is negative 2, you see with your own eyes that A is 1, draw it, because that's kind of what the questions are based on. All right, so they ask us to analyze this. Notice how it has an X and a Y. So we're going to complete the square and isolate the square part and even factor this. So this process is not really something we've done, but there's an X side a y side. These were the parentheses we're really trying to get. So complete the square. This we've done. Add half of this squared, so cut it in half and square it. So we get a perfect square. And then this side, well, if you add 4 here, you have to add 4 here. The parentheses came about by factoring. But that equation gives us everything we need to know about this graph, This would be a fairly hard thing to graph just by staring at it. But by putting it into this format, we know everything we need to know. X is being squared. So let's see, what do we know? H is 2. H is what we're subtracting from the X. So it travels with the X. H is 2. K is -1. And A is 1. Because remember, a 4A would go there. So with all of that information, 2, -1, go up 1 to find the focus, double whatever A is left and right to find these 2 points, and we can draw the point. They'll also ask you for the equation of the directrix, possibly, on some homework problems so you can see it. All right, we're not really going to do these word problems. They might be kind of interesting where they give you something, but yeah, we're just not going to do them. So no word problem. So it stops right here with a new way to graph parabolas. Let me call up probably the most important table. Not this one with the HK, even easier than that. I think this table, I know scrolling through this on video is, sorry, so bear with me. All right. This one right here. We have equations that the author is going to write like this, and I describe them as we're solving for the square, the squared variable, and we want a number sometimes between the minus sign and the other letter, sometimes just a number by the other letter. So if you have that and you just kind of pay attention to what's being squared, if y is squared, opens to the left, to the right, to the left. If x is being squared and things are negative, it opens down. And if things are positive, where am I looking? I saw a negative sign, but that's not worth negative. If you have something like this with no negative sign, yeah, it opens up. And if you see a minus sign, it opens down. If you get this, it's kind of nice. I mean, it's kind of fun to do problems like this. It's kind of like if you just instantly are given an equation, x squared equals -16x, y rather. I instantly know what this graph looks like, instantly. How it's oriented, how wide it is, where the focus is, all of the stuff that is pretty, kind of relevant to graphing something like this. And that has to do with the number being built into the formula. So what was A? Technically speaking, A is +4, because 4 times 4 is 16. But it does open down. So, and I'm not subtracting anything from X, not subtracting anything from Y, so the vertex is at 0, 0. So hopefully that summary kind of helped a little bit. But all right, this is a good way to kind of unify the idea of the parabola without just restricting ourselves to the two that are functions that pass the vertical line test. I also have parabolas that turn left and right, and you can see the connection maybe here, but I'll leave you with that. On this section, obviously, the goal is to be able to do the homework. So if you're making progress with the homework, hopefully all this helps. Keep whatever notepad you might need and recognize what the minus sign does to everything, including the answers themselves. All right, but that's it for section 7.2. If it's feeling like this was section 7.1, remember section 7.1 didn't have any exercises in it. So 7.2 is the first one that actually had examples.